Today's 4/11. I don't know why that seems like a. Is there something significant about that date? 4/11? Am I missing something? Yeah, thanks. Thanks for that. It is. Look at. Do you see this? 28, I think, is what it probably says. Ooh. So far, to this point in the last month or so, I have shown you how to solve quadratic equations by factoring. I showed you how to solve quadratic equations by using a computer to make the graph and trying to see the places where the graph crosses the x-axis. And then last week, we worked on solving using the quadratic formula. So today, we learned something that we need to do the last two methods. So the last two methods are today's, which is using square roots, and then starting, I don't know if it'll be tomorrow, maybe. We might do some Y-top practice tomorrow because Y-top starts in 2 days. 2 days. But the last method is completing the square. And so we need today's skill to be able to do completing the square. So after this, then we'll be like, wow, we can solve anything. So anyways, today's method is using square roots. So I guess when all is said and done, you'll have 5 different flavors. You'll have factoring, which we already talked about at great length. You'll have graphing, which again, we let the computer do the graphing for us at this point in time. You have the quadratic formula. So all 3 of these I'm check marking because they're in the books. We've done it. We know how to do it. And then the other 2 methods are, again, today, square roots. And then either tomorrow or Friday, kind of depends how the week goes. The last one will be completing the square. So this is what we're doing today, is using square roots. I don't think you'll find too much difficulty, but I've been wrong before, like a lot. So let's see how this goes. Let's talk first about a really basic quadratic equation like this. Assuming that you know your times tables, which is something I think I'm within my rights to do as a high school math teacher, you should look at this and have an answer for me pretty quickly. Yeah, and the most common wrong answer that I get is this. And it's not so much that it's wrong, it's just incomplete. So this is something that we kind of want to coach out of ourselves here today, is this idea that there's only one number in the world that if you square it equals 49, because I'm pretty sure there's another one too. Can you think of who he might be? Yes. And that right there is huge. Don't forget that when you think about squaring something to equal a number, there's a negative number that can square to make it just as well as a positive number. So the way we write this is, instead of writing x equals 7 and x equals -7, there's nothing really wrong with this. But the way we choose to write this is x equals positive -7. That's a notation you're going to want to start to getting you're going to want to start to get used to that, because there's a lot of times when we quite literally need that notation. So like in a case like this, if you put x equals 7, comma, x equals -7, I'd be like, okay, that's fine. No harm, no foul. But like I said, there will be points even in this lesson today where not writing it with the positive negative sign is going to be a real kind of a booger. Not wrong, just a problem. So let's do another one. X squared equals 4. What is X? So positive, negative 2. I say get used to writing that symbol today. Remember that 2 when you square it equals 4, and negative 2 when you square it also equals 4, right? Okay. So what we're actually doing in a case like this is we're taking the square root of both sides. I think you probably could figure that out, that if you think about it, like, why does this happen the way it does? Well, it's because we took the square root of this side, and that's what led to just regular X. And then we also took the square root of this side, and that's what led to positive and negative 2. Ordinarily, if someone said to you, what's the square root of 4, you would just say it's 2, and you'd be right. That's fine. We call that the principal square root, the positive version. But when we're solving equations, we need to consider both possibilities. Okay? How about something like this? We hit a bit of a mental block or a wall in a case like this because why? It's not a rootable number. So in a case like this, we say X equals positive, negative. Again, just get used to writing that without even doing any math. Before you even do the math, just instinctively write positive, negative. And I'm going to write 2 root 5. Now, inevitably at this point, we have to have a conversation about where did that come from? Well, again, look at the green thing that I wrote up above. Remember, we're taking the square root of the one side and we're taking the square root of the other side. And as we know, you can't square root 20 explicitly and get a nice whole number, right? But we can tree it down. What two numbers multiply to make 20 that we care about? Right. And so here we find ourselves again breaking down square roots. So instead of just calling it the square root of 20, which is unacceptable, we call it 2 root 5, which is why. How about this one? We know 45 is not itself square rootable, but we do also know that he has a pair of factors that we are interested in. What are they? 9 and 5. So again, in its raw form, we would have, yeah, the square root of 45. But we know better than to leave it like that. Like, we practice this stuff for a reason, and we know to go branch, branch, root, root. And in there, we put 9 and 5. We're not interested in 3 times 15. We're interested in 9 times 5. What's the square root of 9? So we say then that X equals positive, negative. What? Good. So far, so good. Okay, so that's a basic, simple quadratic equation where you just take the square root of both sides and then you work with the number on the right. Sometimes it comes out nice and sometimes it comes out, and sometimes, honestly, you're just going to get trash. Like if I gave you x squared equals 10, right? 10 is trash, but we still have to acknowledge that we're taking his square root. So x equals what? Don't ever give me answers until you say positive, negative. I'm going to try to beat that into you today with just repetitive hitting, hitting, hitting. X equals what? Positive, negative. Nope, just root 10. 10 is one of those numbers. Remember, if I go over here and I make a square root of 10 and I ask you to make a tree, you're going to hit a wall. You're going to realize that the only factors of 10 are 2 and 5, right? Neither of which does me any good. So this is one of those instances where I just have a dead root and I just present it as a dead root. So positive, negative, dead root is a possibility. Positive, negative, whole number is a possibility. And positive, negative, simplified root is a possibility. Those are all things that can happen. Right? Let's take a look at what happens now if I start putting some things with my x squared. So for example, 4 plus 3x squared equals 28. You should have good algebra instincts by the second week of April. Like by this point, I've never asked you to solve an equation quite like this, but you should just have an instinct that tells you what to do. Take a shot. Right. Subtracting 4 is just already in your blood. Like you just understand instinctively that that's what you're supposed to do. So if I subtract 4 from both sides, I'm left with 3x squared equals what? Very good. And again, follow your instincts. We're not ready to square root yet. Why? Because we have to divide away that 3, right? We just know based on those first 4 or 5 examples what this needs to look like. And so if I divide away the 3, then I get to where we've been to this point in the lesson, and we say that x squared equals 8. And now we know what to do, and that is to square root the left side and square root the right side. So we're going to say x equals what? Positive, negative. Very good. And again, feel free to take your time. I mean, it's not a race, right? And so if you're uncomfortable with making this jump the way Tegan did, then don't. Go off to the side and show your work. Show, okay, I'm taking the square root of 8. I'm going to show myself making the tree, branch, branch, root, root. And what numbers am I interested in? 4 and 2. And what's the square root of 4? There's your 2 root 2. So far, so good? All right, good. The next one I have for you is 21 minus x squared equals negative 9. ¿Qué tenemos que hacer primero? Again, follow your instincts, please. What should we do first? Subtracting that 21, you just know in your heart is the right thing to do. Now, the issue with a problem like this is that if I subtract 21, I want you to notice that all of this stuff is still here. So when I copy it down, don't be a rookie and write down x squared. You want to write negative x squared equals. And what is negative 9 minus 21? Negative 30. Are we ready to square root now? Nope. Got to get rid of that negative. And how do we get rid of pesky negatives that are attached to things? We divide by a negative. And you can divide by, some people divide by a negative. Some people say I'm going to divide by -1. It's literally the same thing. But when I divide both sides of this equation by a negative, I get to where I've been in every problem before this. X squared equals a number. So what's the next step now? Square root both sides. So I get x equals, it is, but I'm waiting for you to say those 2 lovely words that I'm just not going to budge on. Positive, negative. That's a killer for people. Before you even worry about the root, stick your positive, negative in there. And yes, you're exactly right. 30 is a dead root. 30 has a lot of factors. 30 can be made with 2 and 15. Trash. 3 and 10. Trash. 5 and 6. Trash. So 30 is an example of a really big number that we feel like we could break down, but we actually can't. So far, so good? I put 2 of these on my note card just because I know that negatives in front of variables can cause some issues. So this is very similar to the last problem. The ending is going to feel a bit different, I think. But what is step 1? Subtract 15, which is going to lead us to what? Perfecto. And now what do we do? Divide by that negative. Get x squared equals regular 16. So what is x? Positive, negative 4. This goes back to the beginning of the lesson when we just get a nice number. You know, and sometimes that happens. It's nice when it happens. You can't put the root sign. It wouldn't make sense to put the root sign because the square root of 16 is literally just 4. Yep. So it's time to move on to the second half of this. Are you guys okay so far? Okay. Again, I can only ask of you that you just follow your heart here. You know what to do. What do you think it is? -4. Yeah. Your spidey sense by this point in the lesson is just telling you that this thing that I'm putting in this golden box is very important. That's called the square. And you want to get the square by itself so that you can unsquare it with a square root. But job one is to clear away any excess garbage. In this case, the 4 is the garbage. So I'm going to copy down my square, my x minus 3 squared. And then, of course, 9 minus 4 is 5. You don't want to mess that up, right? Now, this part might confuse you a little bit, okay? If everything has felt super easy to this point, just watch out. This step can be a little bit weird. Not this step, but maybe the next one. So we do have to now square root both sides, just like before. It's not going to say x squared in every problem. It is, however, going to say something squared. And the something in this case is x minus 3. So if I square root the left side, if I took this and took a square root of it, what would I get? Yeah, you just get x minus 3. Whatever's underneath the exponent of 2, when you square root it, you're just going to copy that down basically, because the square root and the square basically just kill each other into oblivion. Equals what? Thank you. I should give you a reward. If I were a rich man like Bill Gates, I'd give you $100 right now just for saying positive, negative. Thank you. And what is the square root of 5? There isn't one, so I'm just going to write root 5. With what? I was just doing that to make a point. We square rooted both sides, but that I was just showing what I was doing there. But that square root, this yellow square root, and this blue exponent of 2 are called inverses. They just cancel each other out, which is why in the next step I just write the x minus 3. Got it? We're still not done though, right? Because we don't have x by itself. What do we have to do now to finally get x by himself? At 3. So the way this answer is going to look is a little bit weird perhaps to you, but when we add the 3, we want to add it and we want to tuck it right where this red arrow is pointing. That's just what we do. So when I put my new and improved plus 3, I'm going to write my answer as positive 3 plus or minus root 5. You get used to answers that look like this. There are going to be a lot of them in the next week. So that means that my two answers in this case, if someone said, hey, tell me what that means, what are the two answers? Your answers are actually 3 plus root 5 and 3 minus root 5. We've seen that before. I don't want you to write it like this. I just wanted to show you that there are two answers in there, right? The plus path is one answer, the minus path is the other. Let's go again. Remember the gold box, this funny shaped box thing is our priority. I'm saying to myself, I need to get you by yourself because I can't do that fancy square root thing until you are isolated. So who ought to go first? That -2 is always the one we're going to get rid of first. We've been hanging around each other long enough to know that that -3 can just wait his dang turn. So first thing we're going to do is add 2 to both sides. And that's going to get us -3 times the thing we're trying to get by itself equals, and again, we can't make mistakes on this. What is -26 plus 2? It is -24. Not ready yet. Still, I got to get that power thing. That's what we call that, the power, the square. Got to get that by itself. What do I do now to make it official? Divide by what? -3. Very good. And if I divide, I'm going to show my work on this step just because I feel like it. Because if I don't, I think that someone might say, how did you do that? So if I divide by -3 on both sides, those -3's cancel. And I'm left now with x plus 4 squared equals what? 8. And I imagine now that this probably looks familiar. By this point in the lesson, you now realize that, hey, I've seen them like this before. What is now the next step? Square root both sides. And again, I'm not going to show my work. I don't want there to be any confusion, but I am square rooting the left side. And when I do that, what do I get? I just get x plus 4. Square rooting just lifts off the square and the parentheses, and that's exactly what we're going for. Equals what? Thank you for saying positive negative. You also would have gotten a money prize if I were a wealthy man. Well played. Good job. 2 root 2. Because, of course, that's the acceptable version of the square root of 8. And what's our last step? Right. And remember that when you subtract this 4, it's not arbitrary where you put it. You're very purposely going to tuck it right where that red arrow is pointing. Always, when you have a last step, that's a plus or a minus, always tuck that number right in front of the positive negative sign. So what's my final answer going to say? X equals? Good. And I won't fight with you about this. Eventually, you'll either coach this into yourself or you won't. It's not a battle that I want to fight, but you'll hear me try to set good examples. This symbol that I'm circling in yellow, we refer to as so when we say it out loud, properly speaking, we should refer to the one that I've circled in yellow as positive negative. The one that I'm circling in blue, I heard Tegan say it, well done. We now switch our words and we say plus or minus. And the reason is because there's a difference when you put something in front. So like if I put this number, and again, I won't harp on this after today. I'll just let you coach it into yourself. But if I put this number on the board, read that number to me. What do you say? Yeah, like literally no one except the weatherman says -5. You'll hear weathermen and weatherwomen say like, oh, the temperature's -5. That's okay, like whatever. But we know that as a number, we say that as -5. We would 100% of the time say -5. But the moment I put this in front of it, read me that math problem now. You see how it changes into a verb when you put a number in front of it. So that's why the yellow one up there is positive, negative. The blue one is plus or minus. So not a lose points kind of thing, not a worth fighting about kind of thing. But if you want to do this the best you can, know the difference between an adjective and a verb. It's an adjective when it describes, it's a verb now when there's something in front to create action. So, but I won't bring that up, hopefully, anymore. How about this one? I wrote all these examples last night, and whatever uh, impetus or inspiration there was, I'm just going to give them all to you because they all had a purpose in my mind at 9 o'clock last night or 9:30 when I was writing these down. So, how about this one? Add the 4, right? So I'm left with 5 times the thing I'm trying to get by itself equals 1 plus 4, 5. Now what? Divide by 5, which gives us thing we're trying to get by itself equals 1. 5 divided by 5 is 1. And now it's time, we're green lighted to do that thing that we're doing today, all day today, and that is square root both sides. So what will my left side now say? Equals. Good. And I noticed that we didn't say root this time because this is one of those times when I don't need to say root because the square root of 1 is literally just 1. It'd be the same as if it was a 4, we would just say 2. If it was 100, we'd just say 10. Like if a number can be square rooted, by God, square root it. Next step, move that 5, add the 5. And remember that where we tuck the 5 is something that this I will hold you accountable for. It needs to go there. So what's my next line going to say? X equals. Good. And thanks for saying plus minus. Remember, he was a positive negative sign until we put a number in front of him. And now this is a trace the pathways problem. You've seen this with the quadratic formula. Now I remember why I wrote this problem. The pathways have to be traced now because the numbers are all rational. There are no more roots. And so this is an example of a time when we have to trace and get 2 separate answers. So I'm going to circle the plus sign in yellow. What is 5 plus 1? So one of our answers is x equals 6. I'm gonna circle the minus sign in blue. What is 5 minus 1? So our other answer is x equals 4. So in a case like this, you are required to write your answers out separately because they're rational. We don't leave rational answers as more work to go. 5 plus or minus 1 is not an acceptable answer. 6 and 4, that's an acceptable answer. I have 2 more examples for you, okay? Oh, that's supposed to be a 29. Why are you calling me? Why? Hello? Yeah, hang on a second. What's step 1? Subtract the 3. This is a very different situation. As I was clicking through your Delta Math assignment, I tried to do a good job of finding all the different types of problems so that you didn't get to one where you go, hey, you didn't show us this. And I thought this was an interesting, almost confusing scenario. So yes, I'm going to subtract 3 from both sides first. And I'm left with 2 times x squared plus 7 equals 29 minus 3 as well, 26. And what's next? Divide by 2, which now means that I can get rid of the parentheses. The parentheses are only there in this case to hold x squared plus 7 together while they get multiplied by 2. But if the 2's not there, then the parentheses are like, hey, I'm peacing out. Like, I don't need to be here anymore. So we're actually now just left with x squared plus 7 equals 13. And this now feels, oddly enough, like one of the first problems we did today, where I got to subtract 7. So here I find myself again getting something by itself. If I do minus 7 on both sides, I'm left with x squared equals 6. And now we're home free. What's that last sweet step? Square root both sides. Those 4 sweet words. Square root both sides leaves us with x equals positive negative what? Just root 6. That is a dead root. You know, at 2 and 3, not going to do me any good. Okay, one more example. You guys feel like you got this? All right, good job. Great job. So last one. And I don't necessarily know that this serves a specific purpose. This one might be redundant, like we've done one like this. I think every other one has kind of served a purpose. This one I feel like is going to be a bit recycly, but let's see. Right, no hesitation. Subtract that 25, and we're left with 4 times x minus 9 squared equals 20. Next step, divide by 4. And this time I cannot take off the parentheses because the parentheses are still needed because all of that x minus 9 is being squared. So perhaps that was my thinking last night was let's look at the difference between when can the parentheses go bye-bye and when can they not. In this case, if I divide by 4, I still need to trap the x minus 9 because they're still being squared. And 20 divided by 4 is, of course, 5. Now what? Those 4 sweet words. Square root both sides, square root both sides. Beautiful. And so we're left with x minus 9 equals what? Right. 5 is a dead root, but we're not done. What's the last thing we have to do? Move that 9. Remember, we tuck it right there, boop, every single time. What's my final answer going to be? Bless you. Done. And this is not one where you trace the pathways because root 5 is irrational. So this time we just leave it as 9 plus or minus root 5. You'll see in Delta Math today when you're typing in answers that there should be a button. There's a button for plus or minus or positive, negative, whatever you want it to say. There's a button for that. And there's also a button for the square root sign. You've seen that before, I think, but if not, just know that both of those buttons are there for you. So it's assignment 28. It's on Delta. I have it due Thursday morning, I think at like 8 o'clock or something like that. So I don't think you'll get it done today. That's a lot to ask of you, but that's where we're at. So any questions? Good, good. All right.